Welcome back to the King Tutorial class. In today's class, we're looking at calculating angular distance 2. Now, we'll be continuing from where we stopped in our last class or on the video. Now, we have number 3 and 4 remaining. To those who tried it out, very good. To those who didn't try it out, no problem, that's also very good. And number 3 says P and Q are two places on the same circle of latitude 79 degrees south. So now remember I said latitude usually come before longitude. So I have 79 degrees south, 79 degrees south, since they're on the same latitude. So automatically that's what I should have the points to be like. Now P is on longitude 68 east. P is on longitude 68 while Q is on longitude 22 west. Q is on what? 22 west. Very good. They now said the angular distance between P and Q is dash. Now, how do I get the angular distance between P and Q? Very simple. Solution. Two modes of solution, mathematical and what? Graphical. So, mathematically, what do I have? Now, look at this. I have 79, 79. The value is what I'm concerned about or concerned with. Now, not the poles. Since these values are the same thing, automatically I'm going to what? Eliminate this and work with the lines of what? Longitude. Now, you can see this question is very different from the last ones we've been solving. Now, in this case, this is east and west. Different poles I'm going to what? Add. Automatically, the angular distance becomes what? 68 degrees plus what? 22 degrees. And that's what? 90 degrees. Simple as that. Now, our angular distance is noted as what? Theta. I should have said that earlier, but it's not so too late to know. Okay, so our angular distance here is what? Is theta. That's just the symbol. So then graphically, how does it play out to be? Now, graphically, I'm going to have my sphere like so. And in this case, this is my what? GMT, 0 degrees, and my what? Equator, 0 degrees. Now, remember, P is what? 79 degrees south. This is south. 79 degrees is very close to this guy here. So let's assume this is where it is. 79 degrees south. And 68 degrees east. This is east. So something like this. Something like this. This is what? 68 east. Okay, for you, make sure you draw this very well so you can see it very much well. I'll just try zooming in well so you can see what I'm doing there. And we also have 79 degrees south, 22 west. This is still the south. 22 west now becomes like this. Something like this. So this is my what? 22 west. Now, coming in, what do we have? It means that this point of intersection, this one represents my what? My P. Is that okay? This represents my what? My P. This represents my what? My Q. Now, in this case, what do we now do? What I say we're going to do is what? Trace this intersection, point of intersection to the center. Trace this point of intersection to where? To the center. Now, how does it play out? In this case now, from here to this point is my what? Is my P, which is what? 68 degrees east. 68 degrees. And from this point to this place is what? My Q, which is what? 22 degrees. Now look at it if I enlarge it. Something like this. Now I have something like this. This place to this place is my P, which is what? 68 degrees. So automatically it means this place is 68 degrees. That's what we've been saying so far. And then in that case also, this is my Q, which is what? 22 degrees. Now, if I'm to calculate the distance between P and Q, it means I'm calculating it from this point to this point. If it's from this point to this point, it means I'm going to calculate from this point also to this point. Now, what would that be? That becomes addition. Automatically, I'm going to have that what? 22 plus what? 68 degrees, and that's what? 90 degrees. As simple as that. Now, for the final question, which is number 4. It said the positions of two countries P and Q are this and this respectively. What is the difference in latitude? Now we have P as what, which is number 2 here. Number 2, we have P as what, 15 degrees north, 12 degrees east, and then my Q to be what, 65 degrees north, 12 degrees east. Okay, coming back to solution, coming back to our board, what do we have as the answer? Mathematically, what am I going to have? This becomes what, 15. Okay, now, okay, look at this now. We have the same values here. We have the same poles. We have different values. We have the same poles. So I'm going to eliminate this. Now, in which case, the angular difference, which is theta, now becomes what? Since they are the same poles, I'm going to subtract. That becomes 65 degrees minus what? 15 degrees. As I said before, even if P comes before Q, and this is smaller than this, if we are subtracting, I'm going to use the big against the small. Now, let's see it graphically very well. Graphically, how will it look like? Okay, let me try and open it up. So I have my Greenwich meridian. I have my what, equator. Then we have what, 15 degrees north, so very close to this guy here. This is 15 degrees north. And then we have 12 degrees east. This is east, so also very small, 12 degrees east. So automatically this is my point, what, my point P. Very good. Now, and then we have 65 degrees north, so it's higher. That's 65 degrees north, still 12 degrees east. So this is my point, what, point Q. Now look at this. This I'll trace to the center, which is here. This I'll also trace to the center, which is where, here. Let me bring it out so we can see what we have on board clearly. Now what I have here is exactly the same thing as drawing this out. Okay, and then I have this, I have what, something like this. Now from this point to this point is my Q, to this point I mean is my Q, because this is where Q starts from. This is my origin, so that's my Q, which is what, 65. It means this whole value here is what, 65 degrees. And it now said what, P from here to here is what, 15 degrees, right? So that means this small place, only this small place is what, 15 degrees. If this place is 15 degrees, I'm to find distance between P and Q, which is from here to here, which is this first one. If it's this first one, it means I'm looking for what, this angle here. Now remember, the total is what, 65. This part is 15. This part becomes what, 65 minus what, 15 degrees. I believe you now know how to use the diagram to get the angular distance of a particular question in latitude and what, longitude. Okay, so these are the answers.